Right, we're going to take a look at sequences and series. So this is just sort of an introduction to our new unit. So a sequence, that's an ordered list of numbers. So we just have a whole bunch of numbers that are in a specified order. We refer to some arbitrary term out there as the nth term. If we have a finite domain, so say we're going out to a sub 10, we have a finite sequence. We're mostly going to be concerned with infinite sequences, sequences that just keep going and going. Right, to determine if a sequence converges, we take the limit as n goes to infinity. So here's our sequence, take the limit as n goes to infinity, which is 2. So we would say that this sequence converges to 2. And here's a visualization of what that looks like. If you want to know if this one converges, take the limit as n goes to infinity. Need to use a little bit of algebra here to simplify this down. That gives us 0, so this sequence converges to 0. And you can see that those terms decrease rapidly towards 0. Limit as n goes to infinity, we can simplify that algebraically. And this is infinity, so the sequence diverges. So those terms just keep getting bigger and bigger. For sine of n over 3, well, you have to think of what happens with sine of n. It bounces around, gives you numbers between -1 and +1. And so this sequence diverges. And you can see that right here pretty clearly, that as n gets bigger, it's the terms are just completely random between -4/3 and +4/3. The absolute value theorem for sequences tells us that we can take the absolute value of a sequence, take that limit as n goes to infinity. If it is 0, then the original sequence converges to 0. So this sequence here alternates positive and negative because of that -1 to the n on top. So we take the absolute value, which just turns that into a +1 over n. Limit as n goes to infinity of that would be 0, so this sequence must converge. And you can see here the terms go positive, negative, but always getting closer to 0. Here's another sequence where the terms alternate positive and negative, but in this case, we'll see when we take the limit as n goes to infinity, the terms do not go towards 0. Compared to n to the 4th, that +1 is insignificant, so that becomes root n to the 4th, which is n squared. Simplify that down, and this becomes the limit of -1 to the n times 3/2, which means the terms are getting closer and closer to +3/2 and -3/2, alternating between the two. So we would say that this sequence diverges because we don't have a single value that we're approaching. We keep bouncing around back and forth between positive and -3/2. All right, so this brings us to series, which is really the main topic behind this unit. So this symbol right here is the Greek letter sigma. We use this to mean summation. So we could write something like the sum from k equals 1 to 4 of 1 over k. That means start with k equals 1. That would give you 1 over 1, then 1 over 2, 1 over 3, and 1 over 4. And we add those together. So in general, we can write a summation from k equals 1 to any value of n. And we add up all the terms. Okay, so a sequence is an ordered list of numbers. A series, then, is the sum of the terms of that sequence. So if we have a finite series, we would add up a finite value of terms up to whatever value we've specified for n. But we're going to be most interested in an infinite series, one where we add these up forever and ever and ever. And it turns out that if we have an infinite series, if we're adding up infinitely many numbers, sometimes they'll add up to a finite value, in which case we would say the series converges. Or it's possible for those to add up and just keep on increasing to infinity or never adding up to a single value. And we would say then that the series diverges. So we'll be looking into trying to determine how to know if a particular series converges or diverges. All right, so here's the first one we'll look at, and we have an interesting visual to help us with this one. If we start with a square 1 unit by 1 unit, so that has an area of 1, we can take 1/2 of that square. That would be an area of 1/2. On the remaining side, take half of that, which would be a 4th. A half of that would be 1/8. A half of that would be a 16th, and a 32nd, and a 64th. And you can see how these terms correspond to 1 over 2 to the n. We have 1 over 2 to the 1 is 1/2. 1 over 2 squared is 1/4. 1 over 2 cubed is 1/8, and so on. And as we add these up, you can see that we get closer and closer to that upper right corner, which is going to add up to 1. So the infinite series here of 1 over 2 to the n is going to add up to 1, which means it converges. And there are definitely some series where even though the terms are getting smaller and smaller, they're not going to converge. An example of that is right here, and we'll get into the details of this particular series at a later lesson. Okay, so if we're going to determine if a series converges or diverges, the first thing we need to have is the terms approaching 0, which leads us to the nth term test for divergence, which says that our series diverges if the limit does not equal 0. So if we take the limit of the terms of a series, if they don't approach 0, we know that that series diverges. Which means if the limit does equal 0, the series could converge, but it may also diverge, so the test is inconclusive. So to be really clear, and I'm going to keep on repeating this all throughout future lessons, the terms of a series have to approach 0 if there's going to be a chance to converge. But just having the terms approach 0 in itself is not enough to show that a series converges. It might still diverge. So to summarize all of this, we know that a series diverges if the terms do not approach 0. If the terms do approach 0, then we don't know. It may converge, it may diverge. We'll have to find some other way to make that conclusion. All right, so if we have this series here, let's apply the nth term test. So we take the limit as n goes to infinity, which is 1/3. So the terms approach 1/3, which means the series diverges, because we would be adding 1/3 plus 1/3 plus 1/3, which is going to go on to infinity. So by the nth term test, this series diverges. We can apply the nth term test here, use L'Hopital's rule, and we end up with 0. So the terms are going to 0, which means the nth term test is inconclusive. This series may converge, it may diverge. Based off the nth term test, we just don't know. And so the upcoming lessons are going to all cover methods of determining if a series converges or diverges.